Okay. Hello everyone. So I'm Sylvain, and I will give a quick update on the GHC modularization effort that has been ongoing. So first, why do we want to make GHC more modular? So Gargo's talk this morning was a perfect introduction to this one, because we would like to adapt it for new use case, new tools. At IOG, our particular use case is to make it better for cross-compilation. So we want to make it multi-target and things like that. So I'll jump to this one. So for those who don't know, the GHC API isn't so good. So if you're not familiar with it, would recommend watching this talk by Neil Mitchell. It's online. Where he described and runs a little bit about the API. And so the usual solution to work around the problem in the API is to either wrap it, usually to wrap it into a Seiner API, more high level or something like that. So that's what HLS or HLIN or the new compiler are doing. Or maintaining a fork of a GHC, so that's what we do at IOG, that's what we seem to do with the new compiler. The external STG interpreter so does this. And there is a third solution, so that's the topic of this talk, it's to fix it. So that's what I started to do a few years ago. So these are the modules of GHC 810. So the first thing I worked on was to introduce a module hierarchy that would match the compiler structure architecture. So for each box in the compilation pipeline, we would have a hierarchy in the modules. So why would we want to do this? It's useful to identify a layer violation. For example, in one box here is using a module from one box here. It may be an indication that something isn't right, because you can use one box without using the other, and perhaps in your case you want to replace one of the boxes, and basically reducing coupling. So the first step was to make it easy to identify coupling by introducing this hierarchy. So this took 3 years. And so now we have this, and we are in the second step, that is actually fixing the layering violation in the code, making each box easier to reuse, each subcomponent easier to reuse. So a lot of work has already been done. It's tracked in the tickets. And so he's not here, but basically Simon Payton was always asking what's the ultimate design we wanted to reach, as it's a lot of churn in the code base, refactoring the code. And as he said also this morning, he wanted to have an idea of the ultimate design of the GHC API, what we were reaching for. So the problem is that no one agrees on what the design of the GHC API should be. So instead what we do is that we use a bottom-up approach, where we try to isolate each subcomponent to make it usable on its own, and to push the glue code between the different components into the driver code in the compiler. So I've tried mostly to explain to define the concept I was following to refactor the code, basically. And one day I read this book that I highly recommend, Domain-Driven Design, and I was reinventing what they were discussing in this book. So we wrote a document, a paper with Jeff and John, that explain how to match concept in the book with GHC, how to apply the concept to GHC. So this was earlier this year, and we've got awesome feedback, so that was great. And so this is my last slide. So the current status is that there's still a lot of work to do. The canonical example is that the parser still depends on half of the compiler. Yeah, as long as it depends on the driver, it depends on everything else. So, yeah. We've had a lot of positive feedback, so that was really encouraging. And also, it drove new contributor to GHC to help with this, because it seems quite simple to contribute to. And we had a Google Summer of Code this summer, Dominique Bettler. And so the conclusion is that if you want to help with this effort, feel free to join. There is a lot to do. Yeah, so it's a call to harm. That's it for me.